In mid-February 1943, at Sidi Bou Zid, Mamoun Ahmed. In mid-February 1943, Sidi Bou Zid, Tunisia. The seized M4A1 Sherman tank came to a halt in the desert sands, its American star still discernible under a quickly applied German cross. Officers from the Heavy Panzer Battalion 501 assembled around this valuable capture, notebooks ready for notes. The capture of this single fully functional American tank during the Battle of Sidboid initiated a confidence crisis among German engineers that would reverberate through their armored vehicle development efforts for the war's remainder. The calculus of tank warfare was about to shift, not due to enhanced gunpowder or heavier armor, but thanks to something the Germans had previously disregarded: a level of automotive reliability that would not yield under stress. The tank displayed the name War Daddy 2 on its side. Its serial number was USA 3,067,641, produced by the Lima Locomotive Works and assigned to Company G of the 1st Armored Regiment, 1st Armored Division. Members of a German reconnaissance squad drove this Sherman 350 kilometers over the North African desert to the port of Sfax, completing the trek in 4.5 days. With each kilometer, they discovered features challenging their preconceptions about American industrial skills. The engine experienced no overheating. The transmission worked flawlessly throughout. The final drives continued to perform reliably. German tankers, used to making numerous mechanical pauses even for short journeys, grew increasingly uneasy as they watched this foreign vehicle perform without trouble across landscapes and under conditions that typically crippled their own machinery. When they reached the port, War Daddy 2 was placed aboard a freight vessel headed for Germany. The Army's Weapons Bureau had given clear directions. This tank had to arrive at the test center in Kummersdorf undamaged and still operable. German intelligence only had incomplete reports regarding American tank output. However, witnessing the actual tank turned such numbers into tangible evidence in a way documents never could. The Sherman stood for mass manufacturing at a scale beyond Germany's reach, constructed according to automotive design concepts the Germans had yet to achieve. As the vessel traveled north across the Mediterranean, Wehrmacht engineers got ready with testing plans that would yield insights they had resisted confronting, both about their shortcomings and American strengths. In the spring of 1943, at the Kummersdorf testing grounds in Brandenburg, Germany, War Daddy 2 was unloaded from a rail freight car marked for Zugkraft 259 and fitted with the German license WHO 58941. The test engineers had already marked all its armor surfaces with measured thicknesses and angles for a detailed assessment regimen. The German Army's proving grounds at Kummersdorf, 25 kilometers south of Berlin, was the main center for evaluating both German and captured enemy vehicles. In this setting, highly attentive engineers meticulously evaluated, tested, and scrutinized aspects ranging from track tension to how efficiently the transmission operated, recording their results in extremely thorough technical documentation. The Sherman was on the verge of facing the most all-encompassing automotive scrutiny that German engineering could produce. Teams of German testing engineers, together with multiple branch specialists, undertook the preliminary evaluation. They captured images of every part from a multitude of perspectives, checked every gap using precision measuring tools, and made note of assembly methods that appeared unreasonably uncomplicated compared to German approaches. Powertrain experts instantly directed their interest toward the transmission. While German tanks used straight-cut gears that demanded tight tolerances and ongoing servicing, the Sherman featured herringbone gears distributing force over several teeth at once. This configuration, a standard in American car manufacturing since the 1930s, yielded outstanding toughness with only minimal precision needed. German engineers had previously regarded herringbone gears as impractical for mass production due to the limitations of their factories and the skill level of their workforce. American manufacturers, however, had already produced thousands of them. The assessment commenced with straightforward automotive exercises constructed to push all mechanical systems to the limit under regulated scenarios. Engineers drove War Daddy through a variety of obstacle courses simulating real battlefield situations, keeping track of fuel usage, observing engine heat, and logging how the transmission responded to different loads and ground conditions. After each evaluation, components were dismantled to check wear marks, searching for evidence of strain, insufficient lubrication, or potential design flaws. The findings went against everything German tank philosophy believed about the essential compromises between function and dependability. The Sherman performed respectably in every test area and excelled in the single category where German tanks habitually came up short: the ability to operate for extended periods without the need for maintenance. The inspection of the powertrain brought to light fundamental differences in design philosophies, shedding light on much of what distinguished American methods from those of the Germans. In the Sherman, the transmission possessed 5 gears for moving forward and 1 for reversing, and gears 2 through 5 were synchronized, making double clutching unnecessary under normal driving conditions. This arrangement resulted in a tank that was almost as straightforward to operate as cars meant for civilian use, demanding only a modest amount of specialized instruction for operators. In contrast, German tank crews devoted significant effort to mastering intricate double-clutch procedures and precise throttle adjustments in order to protect their transmissions from harm. The Sherman's design philosophy was based on the idea that these vehicles would be handled by regular troops with only basic vehicular experience, whereas German engineering presumed the presence of extensively trained experts. The Continental R975 radial engine within this specific Sherman exhibited exceptional adaptability to a wide range of working environments. Observers remarked that the engine continued to deliver stable performance even at temperatures where German counterparts would typically overheat or suffer power degradation. Despite being uncomplicated, the cooling apparatus functioned with notable efficiency. The air filtration system successfully filtered out desert dust without succumbing to the repeated obstructions that frequently hampered German armor in the North African theater. With each component, the underlying philosophy emphasized utilitarian reliability rather than idealized theoretical performance. On June 6 and 7, 1943, at the Hillis-Lean Artillery Proving Ground, Reich Minister Albert Schar was present to oversee a significant conference on armament, which brought together leading representatives from the arms industry alongside high-ranking Wehrmacht officials. As part of the demonstration schedule, there were trials in which German and captured Allied tanks were compared for their ability to climb hills. War Daddy 2 was displayed together with the newest models from Germany, featuring a Panther ACEF DM tank newly assembled and a Ferdinand tank destroyer, which was considered the pinnacle of contemporary German armored warfare technology. Schar, who oversaw German armaments production and reported directly to Hitler, required first-hand insight into the capabilities of American manufacturing and an understanding of how German engineering compared to that of their adversaries. The demonstration offered results that neither Schar nor the German tank engineers wished to admit. The Sherman ascended the testing slope without issue. Its 5-speed manual gearbox, with synchronization from second to fifth, shifted gears flawlessly. Throughout the climb, its engine delivered steady power. The driver maneuvered the tank assuredly, highlighting the operational simplicity that would later define the Sherman. Next came the Panther, propelled by its more potent 700 horsepower Maybach HL 230 engine, which enabled it to keep pace with the Sherman, but only just, and with greater effort. The Ferdinand, weighing 65 tons and featuring an advanced electric transmission, lost power and stopped midway up the hill. Speer observed as the recovery teams worked to get the Ferdinand running again, the humiliating breakdown happening in full view of numerous high-ranking officers and industrial executives. In his later memoirs, Speer described the Sherman's abilities witnessed during his inspection trip to Italy in October 1944. He recorded that evaluations of the Sherman's off-road mobility were highly positive, as the tank managed to climb mountains that German armored specialists deemed unreachable for tanks. He ascribed this achievement to the Sherman's engine, which was exceptionally strong relative to its mass, thereby providing it with superior mobility across open terrain compared to German tanks. This specific benefit was documented by the 26th Panzer Division. These notes from Germany's Minister of Armaments were especially influential within Wehrmacht ranks. Das Reich newspaper published the official analysis on June 27, 1943. That article referred to the Sherman as a notable achievement of North American technical teams and labeled it a commendable output of the North American steel sector. The report indicated that people first noticed the repetitive production and the meeting of the notably ambitious standards set by the North American car industry. The article referenced the gyro-stabilized cannon as the initial effort of its type made anywhere, recognizing the innovation by American engineers in this field. These official remarks, designed carefully for propaganda and to avoid seeming defeatist, nonetheless masked the internal concerns spreading among German technical circles. American armor design was not merely serviceable. It was, in fact, superior in terms of engineering for sustained use on the battlefield.